Geological time provides us with a context to understand the long evolutionary history of life on Earth. However, geological time can be very perplexing to look at from the outside. There are a lot of names. These numbers are very hard for us to get our head around. The lifespan of a human being 60, 70, 80, 90, 100 years old. And we want to discuss things that took place 1 billion years ago. And these are very difficult to put into a context. So let's briefly sketch a template for looking at the major basic events and the geological names that are must-knows to understand the evolution of life on planet Earth. The Earth formed at 4.6 billion years ago. And extending from 4.6 to 4 billion years, we call that the Hadean eon. Now, within that Hadean eon, a lot of things were happening, one of which was the Earth was hit by a large rock body, which we think was the size of Mars. And when it struck the Earth, it blasted material into space and formed the Moon. Now, at 4 billion years to about 2.5 billion years, we call that the Archean. And in that Archean time period is when the original components of life were first evolved on the deep sea floors. Now, the Archean backs up to the bottom of the Proterozoic eon, which extends from 2.5 billion to 541 million years before present. And that time period is really benchmarked by the advent of having oxygen that's produced by photosynthetic bacteria that we call cyanobacteria, flooding the Earth environments, both the atmosphere and the oceans, and transitioning fundamentally based on a biological driven event, an Earth going from no oxygen to oxygenated. Now, that end of the Proterozoic and into the Paleozoic, that was a very important transition that is marked by the advent of having multicellular eukarya actually develop skeletons. So the presence of the first fossilized skeletons is the Cambrian explosion at 541 million years before present. Then that's the initiation of the next eon that we call the Phanerozoic. And the Phanerozoic is broken into 3 components. The first one is the Paleozoic, going from 541 to 252 million years before present. And again, you remember 541 is the Cambrian explosion, 252 is the great mass extinction. The death of 85% of what was living on Earth took place at that time period at the Permian-Triassic boundary, and that's why we call that the PT extinction. Now, there are a lot of theories as to why this took place, but now the most recent one that's widely accepted is that this was a widespread, massive series of environmental changes that would have driven life to extinction, almost complete extinction. Now, that next time period, the Mesozoic era, goes from the Permian-Triassic to PT extinction to another extinction event at 65 million years before present called the Cretaceous-Tertiary, the KT impact extinction. And that extinction event was actually caused by having a meteor hit the Earth and help cause the demise of the dinosaurs. Then the next interval of time goes from the end of the Mesozoic, that meteor impact, into the present day, and we call it the Cenozoic era, starting at about 66, 65 million years before present. In this time period, many, many important things took place, but one of them is that we had the onset of glaciation of our current planet. So the Antarctic ice sheet started forming at about 45 million years ago, and of course, an incredibly important event took place at about 2.5 million years before present, and that is the origination and beginning of the evolution of humans. This context of deep geological time will give us a framework within which to better discuss then all the events that have led up to the evolution of life on planet Earth.